Your teacher probably didn't cover implicit second derivatives, but they still can show up on the test. We'll start the same way we start every implicit differentiation problem, by taking the derivative with respect to x of both sides of the equation. The derivative of x squared is 2x by the power rule. Next, we need the product rule for x times y. We take the derivative of x, which is 1, times y, plus x times dy over dx. Then we differentiate y squared using the chain rule. The derivative is 2y times dy over dx because y is a function of x. On the other side of the equation, the derivative of a constant is 0. Now we'll group all of the dy over dx terms together by factoring out dy over dx. Then we'll move the remaining terms to the other side of the equation. Finally, we divide both sides by x plus 2y. Now we can plug in the point where x equals 2 and y equals 1, giving us dy over dx equals negative 5 over 4. Now it's time to find the second derivative. We'll implicitly differentiate both sides of our new equation one more time. The derivative of 2x is 2. The derivative of y is dy over dx. To differentiate x times dy over dx, we use the product rule. Again, we take the derivative of x, which is 1, times dy over dx, plus x times d squared y over dx squared. Next, we differentiate 2y dy over dx using the product rule. First, we take the derivative of 2y, which is 2 dy over dx, and multiply it by dy over dx. Then add 2y times d squared y over dx squared. Now substitute negative 5 over 4 everywhere you see dy over dx. Finally, isolate d squared y over dx squared. Once you've done that, plug in x equals 2 and y equals 1. After simplifying, you get d squared y over dx squared equals negative 21 over 32, which is our final answer.